Uh, Sir, shall we start? You can hear me, sir. Shall we start?
Yes, sir. Sure, sir. Of course, you can start, sir.
Um, so as we mentioned, we will start with the instrumentation, sir. I hope your college having the instrumentation engineering branch, sir.
No, sir. In our college is not having, sir. Only EC, Triple E.
Okay, fine, sir. Anyway, this part of EC only, sir. I am also EC graduate only, and actually worked in instrumentation, so it can be managed with EC background. So
Yes,
it's
sir.
very system. Sir, what I am trying to say, the instrumentation engineering is nothing but it's devices incorporated to have automatic solutions. How we can say, sir, stored in the top level, and you are getting water from the bore. So morning 8 o'clock, you are starting the motor and filling the water in the upstairs tank. And if you forget, it will get overflowed. And if you forget to switch on, you will get you will not get water inside the house. And some man should be always there to operate the system. So this is one kind of additional burden while we are moving with other activities. So what instrumentation system is a basic principle is to make it manual to automatic system. So if the system is started 8 o'clock automatically, and it is stopped in high level automatically, so no one to have attention on that, and it will automatically work anything. So for that, we should have some devices to see low level of the system at high level of the system and give command to the motor to start or stop. So these are all the things only employed in instrumentation, sir. So the command which you are giving to start motor, stop motor, that is called controlling part. And the controlling element part is a motor. Motor is only pumping the water to tank and stop the water pumping to the tank. And some level sensor detecting the low level and detecting the high level. So these are all the primary devices we used to call, that is called transducer. So this is the way the instrumentation system is working, sir. We will have some devices. We might have seen some. We might have studied about the transducers, converts one form to another form. Yesterday also we shown some flow sensor that is also working in the same principle. The same way, we will have the field devices who have worked based on the transducers, and we will have the control system, which is getting signal from the devices, and required control it will send to the final control devices like motor, opening the valve, closing the valve, like that. Instrumentation and control system of Bantam that studies the measurement. Measurement is the devices that is nothing but a transducers converts one form to another form, and the control of process variable. To control four elements, like temperature, flow, and level. Again, if you take a simple example, water level, rise level, and temperature level, and you are reducing the firing angle by opening the gas knob. So this is by feeling the heart or by seeing the heart through our eye. The eye are going to be a transducer for us, and our hand going to be a controller for us, and our control element for us, and the brain is our control system. So it's a simple example in day-to-day activities. The same way the instrumentation system work in the process industry. For boiling a rice, we are taking temperature level and water level, this and all. It has to be in control. If you have more water also, it won't boil. And more temperature also, it will get completely burned. So these things, so the same will be done automatically by using the devices as sensor and control system and the final control devices. So this is the basic introduction of the instrumentation system, sir. Our base electronics is one of the major role is playing to manufacture the sensors, flow sensors, temperature sensors like that. Flow is the main for us. So this is the way the instrument is. So again, we given brief about the transducer. The transducer is a device that converts energy from one form to another. Usually a transducer converts a signal in one form to the energy to another signal. So here we shown some three sensing devices. The left one is RTD, sir. That is measuring temperature. The middle one is the level measuring device. This is the amplification unit for the measured measured one. It will be in the form of pulse. Yeah, it is for the mainly for the flow. It mainly for the flow. I think it is. I'm not confusing anything. It's very clear, I believe. This RTD is the sensing element. The instrumentation will have the sensing element, control system, and the final control element. These three are the sensing element. Suppose you want to measure one temperature in the process line. You can put the left device RTD, so it will sense the temperature and give the system continuously. According to the set point, it will control the valve and all or the heating element to bring down the temperature to the set point. This is the way the instrumentation system works. This is in instrumentation system, we will be having two type of control system, two type of loop. One is open loop and another one is closed loop. The open loop is nothing but is only measuring and monitoring. The closed loop is nothing but measuring, monitoring as well as controlling. Here you can see in the PPT input that is going to controller, control signal is control process and output is directly we can view what suppose in input if you connect one temperature sensor which we shown in the previous slide, that is like RTD. This is the one, the leftmost one as a input to the controller. You can bring some indicator one RTD if you have. Okay. RTD. So they are bringing the device, sir. Please be online.
Okay, sir. No.
Okay. So so this is the diagram shows that open loop system. Open loop system, as I mentioned. See the camera. Huh? So we will on the camera. Indicator. Indicator.
Top right corner
Participants, you can pin the base electronics camera, then only can able to view that.
This is one type of temperature sensor, sir. Even the ECE people know about this. The principle is PTC, positive temperature coefficient. It is the one type of device to measure the temperature, sir, actually. What it does, when we put into the process, it will, the dip will be exposed to the temperature area. So based on the temperature, it will give resistance as output, sir. So when the temperature rises, it will the output of the resistance also will be rising. Okay. The output of the temperature, the output of the device also rising. So that this resistance will be connected to Wheatstone bridge. So when 0 degree, the bridge will be in balanced condition. There won't be any output. If you get some temperature, it will increase the resistance due to positive temperature coefficient principle, and it will be connected to Wheatstone bridge. Then when the resistance varies, it will get unbalanced and it will produce the millivolts. That millivolts produced millivolts is proportional to the temperature measured in the process. This way it is working, sir. This is the RTD. So how we can say in this PPT we can say sir, you can see the open loop system. It is mentioned as input, no? The input is, we can say this is the RTD, which we are showing now. Okay, sir. This RTD is the temperature sensor. As we mentioned, this is positive temperature coefficient. When the temperature rises, it will give resistance as output and it will be connected to Wheatstone bridge. When the bridge will get unbalanced, it will produce a millivolt. When millivolt is produced, it is proportional to the temperature being sensed in the process. This way, we can say it's a input, sir. Then it will be connected to controller or indicator. In open loop system, we will be having not having the controller is connected to the controlling device. It will indicate only the process, like whatever we are going to measure. If it is temperature, it will be temperature. If it is level, it will be level, like that. Okay, the next one is the indicator, which we are going to show it now. This is the one. I think it is a clarity. So this is the one. The RTD will be connected the back side of the terminal like this. So we can dip into the hot water. From here, it will show the front. It will show how much temperature is here in the hot water. Okay. So in that in this open loop system, we given as an example, we are measuring the temperature and we are indicating how much temperature inside the, you can say example as water bath. How much temperature is measured and it will be indicating in the controller. So in that ECE people may be knowing much. So we are using positive temperature coefficient as a principle of that transducer, and we are connecting to the bridge network, Wheatstone bridge network. From that, the produced millivolt will be connected to, it will be converted to analog to digital using A to D converter, and it will be connected to the microprocessor indicator. This is the one. So where we can program everything. How much temperature should it read? How much, if it is this much millivolt means, how much temperature it has to show in the display. This kind of things we can configure in the micro controller like this. So is this from device, transducer, Wheatstone bridge, A to D converter, and microprocessor. All will be incorporated to measure one simple temperature and indicating only for that. It's a brief idea about the temperature sensing as an example for the open loop system in instrumentation. The next one is the closed loop. With the closed loop system, sir. What we are doing here, so in previous, what we talked about, we are measuring the temperature, we are indicating. So everybody can monitor, but nothing can be done. If they want to do something, they can do manually. It won't be automatic. In closed loop system, it will measure, control the thing in this system. We can put 60-degree, we have to maintain in that temperature bath. If you put like that, what will happen? It will sense the temperature. Once it's exceeding 60-degree, it will switch off the heater. When it is less than 60-degree, it is switch on the heater. So this way it will control automatically. So the final controlling device is the heater here. Use control also. For that, suppose example, you are allowing steam inside the bath. Heating up the water. Water bath, allowing the steam inside, it will reduce the steam flow, increase the steam flow according to the set point required for this particular temperature bath. Continuous control we used to call PID. That I don't want to go deep into that. Everybody will get bored without knowing that. Loop system will be working like this. So our instrumentation system is mainly transducer principle method for measuring as well as for the controlling part. And the control system will be based on the microprocessor based, can be configurable according to our requirement, can be programmable according to our main motive. By employing the different field devices, we are measuring and controlling automatically in rather than manual intervention. Without the instrumentation, the process industry cannot run. 1 minute. Okay. So this is the another type of closed loop control system, sir. All this we will have the control system for main process industry where the temperature is a significant parameter to avoid disaster for the particular equipment due to process temperature is getting shoot up or looking for that. We can give as example this programmable logic controller, that is again the microprocessor based. That also controlling the parameter through controlled final control element. This all data again it will be connected to the IoT for remote viewing. We given that example also. Yesterday we practically seen, sir, this one base mechanical flow meters. We seen that kind of flow meters. So these flow meters are the, we can say this is also field devices to measure the flow. Yesterday we showed that one also to everybody. So the same thing, sir. This flow meter, again, how it is connected to IoT system and how it is can be viewed remotely. We talked about that yesterday also. Now, so this IoT you might have seen. So that is the one black diagram we are showing here in the PPT. Here the IoT based smart bin where it can be kept in the designated locations. Designated locations like they are keeping in each state 2 places, 4 places based on the area. High level. Also, it can be traceable through GPRS. So that sensor will give the signal to the centralized web-based station. Like we can say to the corporation, nearest corporation office. There, they will get the alert notification, and they can view which area got the overfilled, attended bin. Then they can send the people that the truck driver will can locate that particular bin with the help of GPRS tracing, traceable GPRS by location tracing through GPRS. He can attend immediately and solve the problem. This is one of the proposed implementation for the smart city. So yesterday we shown that devices, sensor device sensors for that. And that sensors will be kept in the dustbin as shown in the PPT. So next is smart lighting. This is also you can see, sir, in the PPT. The smart light will get on and off. All will be controlled by the one small controller you can see in the front. One controller will be there. That will be having smart socket that will be communicating with the remote station to control all the street lights and everything. This is also one of the required implementation, a proposed implementation for the smart city. Understood, no, sir? Ramasan, we can take that another information. Another one. Okay. Another PPT. No. Another PPT, which is showing all the on we have proposed and we got the project for IoT water flow meter installation in Kerala, Trivandrum. So our assistant manager projects, he will brief about that. I can explain you further. So the Kerala is trying to implement the same thing, sir. So they awarded the project to us. So he can brief about the project. Our Mr. Pradeep is taking care of that product production and project implementation. He will brief about that. I will over to the Mr. Pradeep.
Good afternoon to all. We can see different type of flow meters with different type of IoT solutions. In IoT, there are different type of communication methods are available using GPRS, LoRa communication, and also that Wi-Fi communication. All are wireless communication and IoT only, but the mode of communication only change. Normally, nowadays, our government is implementing lot of smart city projects in different cities, even in Trichy, Chennai, and what Tirunelveli also they are deploying some of smart city project. What right now they are planning to do now? Every house they are implementing water meters. See, currently what we are government is doing for every for small villages or towns, they are giving common connection only. But what right now government is planning, they are planning to provide each household separate line and how much water is everybody is consuming. For that only they are planning to what is the practical difficulties? Na? How much everybody is consumed? That if you want to know, na, every time one person need to go to each location and take the readings and do the billings. It is a very difficult task. Instead of that, we already implemented a water meter with LoRa solutions. What it will do, na? Every month, first date it will send the consumption data to the server. How much? If you consider the consumer number one, he is consuming 500 liters. Now, for that 500 liters only we can bill, and the bill will be generated. The same bill will also sent through email and to the message to their mobile number. Like that, we have installed in Trivandrum project, there are a lot of different type of meters with walls. If you are not paid any amount for that particular month, no, that meters contains one solenoid wall. That corporation will people will automatically close. If particular householder is not paid any amount, no, they will automatically close the wall using the IoT technology itself. There is no need to send the person to that particular location. Like that, we have installed a lot of different type of flow meter solutions for Trivandrum smart city. Those images are available this PPT. There is a different type of flow meters. It is 50 mm meters. That means 2-inch flow meters, and this is 100 mm. It is for normally for not for household. It is for particular village. How much they are consuming. Using this data, why this is very important? Using this data, we can easily arrive particular month how much water is required for this year or next year. We can easily arrive if. Using this data, whether we can easily predict whether the drought or anything will come now, how we can solve this problem. For that, this data is very useful.
Yes, so what he was trying to convey, why the in smart city environment. Now you can say example in Chennai, if you take one housing complex, we have 10 houses. Individual house will be built for 1,000 rupees, irrespective of their consumption. Somebody will use the somebody will use economically the water. Somebody will use lavishly, but all are built in the same way. And we can't predict how much consumption going to be for this year, how much consumption going to be increased or decreased or anything we don't know. Some kind of misbehavior with the water usage we can't even identify. This and all the government want to optimize. That's why they want to implement the flow meter in all individual houses. Also to the distribution network, we discussed about detailedly. We discussed yesterday about that how how it is getting implemented practically. We have an ongoing project for that only. That is the photo representation of that view. We explained everything yesterday itself about that. So how it is getting implemented in Trivandrum, it's our ongoing project. So that's why we are showing all these things to you. You must have seen these devices yesterday. See how it is connected to the lot of server. From there is go to cloud. From there they are receiving in the mobiles. Also remote PC, we can view all the data of the individual consumption. And we will have the separate billing software based on inputs from the remote monitoring station for the individual consumers. It will be they will be sent to that particular people. Now it can optimize. Suppose bill about the water. You water economically. Instead of 1,000 liters, you will use only 800 liters, and you will be paying for 800 liters only. So 200 liters waste of 200 liters water wastage will be reduced. Like that, they can optimize the water consumption. So that is the now we are facing water scarcity, many things like that. So the population also getting increased and demand also getting increased. This kind of implementation method will help the government, help the nation to avoid the water scarcity. So that's why the Kerala is there in front end to implement this, and we are doing that one also. That is this current slide is showing that particular implementation of that project in black representation, black diagram representation. About this one, sir. Shall we move to next one?
Yes.
So you can see how the modular ones is and all is the flow meters where it is directly installed. Okay, these flow meters with IoT capability. Directly, it will be connected to a gateway from the connected. So all this will be connected one nearest IoT gateway. From there, it will be connected to cloud. Through cloud, it will go to water authority. Understood, no, sir?
Yes, sir. Clearly, sir.
Okay, fine. Yes. Now, shall we go for this? The EC people very well knows about the communication. Today life, I can give a suppose you are having one set of box and you can able to view all the channels. I'm having set of only the free channels, and some channels since I didn't pay, I won't get that channels, those channels. How this kind of technology is implemented? Anybody have this idea about that? See, all are in all only, all reference only, all are having, and how if someone is some X not paid the particular channel, how it is not viewable? So how they are doing by means of what they are doing while sending itself, they are encrypting the signal through air. When we are receiving and we are receiving the signal, and that particular software blocking for removing that encryption. when you pay for that particular channel, the software will work and remove the encryption, and it will show it to you. So this is also one of the algorithm to block particular encryption. Remove another software to view all the channels which are encrypted. Is it okay? A little bit I can.